Oh, hi there. Are you as excited to do some delta math together as I am? I hope so. Let's go. We're going to take a look at the new topics in here in forms of quadratics. There's finding increasing or decreasing domains and finding positive or negative domains. I should probably do visual domain and range ahead of that because do the review first. Oh well, I could change that. Yeah, I'll change that. So, finding increasing or decreasing domains. We have been asked to find the domain on which the following function is increasing. Later on, right now we've been concerned with what's the x value, what's the y value, how do those curves line up. But it's also, we're going to be asking questions in physics or in business or particularly in the field called calculus about how are functions changing at different times. If I look at this function, as x increases, y is increasing up to a point. And there's a point where y stops increasing and starts to decrease again. And we want to be able to identify those regions. Okay, so x is increasing between 0 and all the way to the vertex. It looks like the vertex is 5. Okay, so the domain, meaning the values of x, where this function is growing, as x grows, y grows, are between 0 and 5. So let's write that. We would say 0, well, that's less than or equal to x, but x is less than or equal to 5. X is all of these values between 0 and 5 where the function is increasing. So the function looked like this, right? Like that. And this here was the point, I forget what it was 5, we'll call it 520. Okay? And between 0 and 5, all in this range, it's like the rocket is still going up. It hasn't reached its vertex yet. So that's the range upon which that's true. All of these values where x is bigger than 0 and including 0 and bigger than 5 are the areas where x is increasing. So let's see if it gives me the credit for this. I'm actually kind of curious. Yeah. Okay, so that's how you do this one. Let's take a look. See? And then it visually shows you. You see? It's growing, it's growing, it's growing, it's growing. It stops there. That's how you do these types. Let's do another one, because I think I have like 3 to do. Okay, this one here. When is the following function decreasing? Oh, it looks like it's between 5 and 14. Because 5, it reaches its maximum, and then it starts coming down. So I would say 5 is less than or equal to x, which is less than or equal to 14. And one more. When is this increasing? 0 to 3. 0 is less than or equal to x is less than or equal to 3. And the way you type that, if you want to type it all fancy like I do, is you type the less than and then you type equals, and a program like Delta Math or Desmos will give you a less than or equal to. So it's kind of nice. It's nice to be able to know how to type these things. It's faster. Okay, now these ones are positive or negative domains. Another thing we might want to know is, when is the roller coaster under the water? When is the roller coaster above? Or when do we have a positive profit? When do we have a negative profit, i.e. a loss, right? So we might want to be able to analyze our curves in that way. So we want to know, when is f of x greater than 0? Okay, f of x is greater than 0 before it gets to 2 and after it gets to 6. But between 2 and 6, it's below 0. So I would say x is less than 2, or x is greater than 6. And I want less than, not less than or equal to. Is 0 a positive number or a negative number? Neither is the correct answer. So we've been asked for, when is like this function positive? In other words, the bird dives down and at 2 seconds goes underwater, at 4 seconds grabs a tasty fish down there at the depths of the ocean, and then at 6 seconds comes up out of the water all triumphant with its fish. We want to know, when is the bird above the water, not when the bird is right at the waterline. So we want greater than, not greater than or equal to. Okay, submit answer. Don't forget to celebrate your wins. We want to know when this is positive. Okay, it's positive between -4 and 0. So we would say -4 is less than x, which is less than 0. Not inclusive, because inclusive would include zeros, and we don't want those. So that's how that one do. Okay, all of that leads us to my favorite Delta Math topic. Maybe not my favorite Delta Math topic, but I really like this one. And I've been so excited to give it to you. And here we are. We finally get to do 8 of these questions. I really value this one. So, here's how these work. We are interested in this function f of x, but we're not shown a graph. We're not even shown an equation. But we are asked to find where it's positive, meaning where it's going to be above the x-axis. And we can choose, do we want to be shown standard form, factored form, or vertex form? Which one would show us the most clearly when the function is above the x-axis? It's a quadratic. Do we want standard, factored, or vertex form? Vertex form would show us the value of the vertex very clearly. And then we could expand it to standard form and factor it to find its roots. And the roots will tell us where it's above the x-axis. If I could choose one form out of all 3 to just be shown, which one would directly tell me when it's positive? Standard would give me information about the y-intercept. Vertex tells me about the vertex. Factored is correct. If I look at, so think about it this way. We are going to have some quadratic. It might look like this. Pion, pion. Okay? It might look like this, or it might look like this. Okay? If I want to know where is it positive, where is it above the x-axis, I kind of need to know where it transitions between positive and negative. So I visualize these scenarios, and I'm like, you know what? If I knew the roots and I knew the direction of opening, I could tell you where it's positive. So I'm going to ask Delta Math to show me the roots with factored form. There we go. So this quadratic, -3, x minus 2x minus 6. This is one form of the thing. It'll show me the other ones. Oh, I have to wait a while longer before I can change the form. Okay, it'll show you the other ones, and then you could do some calculations and find out this information, or you can just pick the form you want. So pick the form think about the form, be a little strategic. So here, if I am going to analyze that, it's going to look like this. Here's my x-axis. Here's my y-axis. This is a quadratic that opens downwards. It has a root at 2, and it has a root at 6. And it opens downwards, so it looks like this. So I know that x is all these values that are between 2 and 6. That's when the function is positive. So first I need to be strategic and think, what type of information do I want from my algebra? And then choose that form. So I have 2 is less than x is less than 6. Those will be the places where this is positive. Yes. Hooray! Okay. So then, look at that. It shows me a visualization of it. It matches my visualization, so I like that. It kind of clicks in my mind. I'm like, yeah, we're seeing the same things. And I was interested in the roots because I want that particular domain where the dolphin jumps out of the water and goes back down. Okay. Those are the times, 2 seconds to 6 seconds. That's quite a dolphin where it's out of the water. Okay, cool. So now let's do some more. Next one. So I want the y-intercepts of f of x, and I want to write it as a point, xy. What type of form of quadratic should I look at to find the y-intercept most efficiently? Standard form. So let's go. Standard form, it tells me that. What's the y-intercept? What's the y-intercept here for this standard form quadratic? Sorry? Did we break Haley?
That was the red.
Oh, I see. So there is one y-intercept. So there's never two y-intercepts. There's one. Okay, and it's the point 0 in the x, comma, negative 48. I just read it off of this form. It's so convenient. Submit that answer. Yeah. There we go. Correct. Hooray. There we go. Next one. I want to find the intervals where f of x is increasing. Tell me, where is this quadratic going up this way, or where is it going up that way? What form would tell me most clearly where this quadratic is increasing? Standard, vertex, or factored? Tell me, where does a function transition from increasing to decreasing? At what point will it change? Well, this quadratic here, just as like a given example, is increasing, 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 neither increasing nor decreasing. It switches to decreasing. They switch at the vertex. They always transition from increasing to decreasing at the vertex. So, let's use that to find the correct form. We're going to look at vertex form in this case. This one will tell me that the vertex is at minus 1, 32, and it's opening downwards, so I create a little visualization of it. This can happen on your mental whiteboard, or it can happen on a whiteboard or a piece of paper. Okay, so here is minus 132. There's the vertex. And it is opening downward, so it looks like this. Okay. So this is the region, that's the domain, right up to that axis of symmetry, where the value is increasing. So this quadratic is increasing up to x is minus 1. So for values of x is less than or equal to minus 1, it's increasing. That's how this one do. So you want to be strategic about the types of forms of the quadratic that you're looking at. It's going to ask you things like, where does the quadratic have its maximum? Okay, show me the vertex form. Where does this quadratic cross the x-axis? Show me factored form. And it really will help you practice like what each form is telling you about the quadratic at which time. So get some good practice there and enjoy.